Hi guys, this is instructional video 9.3. This is my fourth attempt at this video, so hopefully this one goes well. This is my joke of the day. I'm sure you guys miss all of these. And I also miss teaching you. I probably say that a lot. So this video is going to be about predicting the products of a chemical reaction, but I'm breaking this video up into two parts. So I'm only going to do synthesis and decomposition. You'll have to watch the second one to get all of the information. So the two things you have to really remember before we jump into this is our Brinkelhoff or our diatomics. These are the elements that exist in diatomic form. So bromine, iodine, nitrogen, so on and so forth. When they are alone, only when they are alone, do they exist in with a buddy. So Brinkelhoff is always going to be represented with a 2, iodine has a 2, and so on and so forth. Again, this is only when they are alone. Okay, don't try to do this when they're in a compound. Okay. All right, the other thing you have to remember is the crisscross and reduce method. Okay, so the charge is off the periodic table, and if you don't remember, it's the group number, and then if it's a teen, you ignore the 1. Okay, so for groups 1, 2, and 13, the charges are 1, 2, and 3. For groups 15, 16, and 17, it's 3, 2, and 1. Don't try to put the valence electrons. I know you guys are going to say, oh, well, it's 5 and 6 and 7. That's valence electrons. I'm talking about the charges. So these would be -3, -2, -1, but positive and negatives aren't important for this. So let's jump into synthesis. Okay, there are several rules that we're going to talk about for synthesis. Rule number 1 is a metal and a nonmetal combine to form an ionic compound. It's very simple. This is where we're going to use our crisscross and reduce. So we have Na plus Cl2. Okay, so we're going to figure out what the charges are. So Na is in group 1, that's a 1 charge. Cl is in group 17, that's a -1 charge. If you crisscross and reduce those numbers, you get Na and Cl. Okay, and then you would have to go back and balance this. Now, I think for the assignment, you do not have to balance, so you would not have to worry about this 2 coefficient. You would just have to put the product in, Na and Cl, because it's a 1 and 1. Let's try this one, aluminum and oxygen, okay? So the reason this 2 is here and this 2 is here is because these guys are Brinkelhoff, so they are alone, they have the little 2, but once they are in a compound, that little 2 doesn't matter, okay? Now we're just looking at charges and crisscross. So aluminum is in group 13. It has a +3 charge. Oxygen has a -2 charge. If you crisscross and reduce, which you don't have to reduce here, you're going to get Al2O3, and this would be the properly balanced equation, okay? Rule number 2, let's focus on rule number 2. It says a non-metal oxide combines with water to form an acid. Okay, non-metal, those are those guys to the right, upper right of the staircase. Remember the staircase on the periodic table? And oxide is oxygen. So any non-metal plus oxygen with it plus water forms an acid. Okay, so here we have SO3, non-metal, oxide, okay, plus water is going to make an acid. And I know you guys remember that acids are anything that starts with an H except water, okay? So I know that my acid is going to start with H. Well, how do I know the rest? We're going to do something called the squeeze method, and we are going to squeeze this whole thing together. And to do that, I'm going to have 2 H's because acids start with H, so that's going to go first. I'm going to have 1 S because that's next. And then I have 4 oxygens here. There's 3 here and 1 here. So you get H2SO4. And this is already balanced. It worked out perfectly. I didn't have to go back and do anything. Let's try another one. Here we have another non-metal oxide, plus water is going to make an acid. We're going to do the squeeze method again, okay? So if we squeeze this all together, we have 2 H's, we have 2 N's, and we have 5 plus 1, 6 oxygens. So let's take a look at what we have here. We have H2N2O6. Now for this one, this looks a little odd. I hope you all are saying, well, what's wrong with this one? it needs to be reduced, okay? You can't have 2, 2, 6. This has to be reduced. Now, this one didn't need to be reduced because it just has one S, and you can't have less than one S. But you can reduce these all by 2, and you get HNO3, and then when you go back to balance it, you find out you have 2 of them, okay? So squeeze method, and then reduce if necessary. Rule number 3 is a metal oxide. So now instead of a non-metal oxide, now we have a metal, which is all to the left of the staircase. Again, combines with water, and we're going to create a metal hydroxide instead of an acid here. Okay, so let's start with our first example. Lithium oxide. So we have a metal oxide plus water, and it's going to make a metal hydroxide. Well, this is very simple. You just use the metal they gave you and put it with hydroxide. And I know you guys all remember hydroxide from memorizing your polyatomics. So lithium has a charge of 1 because it's in group 1, and hydroxide has a charge of -1 because you guys all memorized that. So we have a 1 and 1, so it goes together very nicely. LiOH, and then if you went back to balance it, you'd have that 2 coefficient there. Let's try another one. Calcium oxide plus water, we have a metal oxide, okay, plus water. So now we have calcium, which has a 2 charge, and hydroxide, which we just said has a 1 charge. So if you remember your polyatomics, if you need more than one polyatomic, because you crisscross these and now the hydroxide gets the 2, you need to have parentheses. You can't just put a 2 there, otherwise it messes up the whole formula. So you have Ca and then parentheses OH, and you can put that 2 on the outside. All right, rule number 4 says a metal oxide, okay, so just like from rule number 3, it's going to combine with a non-metal oxide, like rule number 2, to form a polyatomic compound, okay? So metal oxide plus non-metal oxide, and we're just going to squish it together and see what we get. So let's try this. Here we have our metal oxide, here we have our non-metal oxide, and we're going to squish it together and see what we get. Now, the best method to use for this is you want to see what polyatomic can I make that I know of. So of those polyatomics that we all have memorized, what could I possibly make out of this? So we have carbons and oxygens. Well, the only carbon and oxygen polyatomic that we have memorized is carbonate, which you all know is CO3 with a 2- charge. So we're going to make that. And CO3 has a 2- charge, and strontium also has a 2- charge. So it's going to come together with a 1-to-1. So Sr, CO3, and it's already balanced. As you'll notice, though, the squeeze method also worked here. It doesn't always work, okay? So I notice I have 1 Sr, I have 3 oxygens and 1 carbon. So the squeeze method would have worked here, but it doesn't always. So for this type of reaction, you're going to have to figure out what polyatomic can I possibly make here. And then here's some more examples. I'm going to have the answers to these at the end. So pause the video and try these out, and then check your answers with the end of the PowerPoint. All right, now let's talk about decomposition. And decomposition is the opposite of a synthesis reaction. If you took a synthesis reaction and flipped it around, you'd have a decomposition. So for rule number 1 for decomposition, these are for binaries. It just means you have 2 elements stuck together in an ionic compound. They're going to break apart into their individual elements. The only thing you have to remember about this is checking for Brinkelhoff. So here's our example, calcium and oxygen. Calcium, these guys are going to break apart, and we're going to have calcium by itself and oxygen by itself. Now, calcium is not a Brinkelhoff. Oxygen is. So calcium doesn't get a subscript, but oxygen does, and then you'd go back and balance this. Okay, this one's very simple. Now, number 2 says when acids are heated, and you guys can recognize that this is an acid because it starts with H's, they decompose into water, that's simple, and a non-metal oxide. Okay, so this is a non-metal, that's the one we're going to make with the oxygen. Now for this, you need to take all of the hydrogens away because hydrogen is not going to stick onto this non-metal oxide. You're going to make as many waters as you possibly can. So the formula for water is H2, right? O. So I'm going to take both of these H's and one of these oxygens, and what am I going to be left with? SO3. So we have water and SO3, okay? Let's try another one. Now for this one, H3PO3, you can't make water with 3 hydrogens, okay? It just doesn't work out well. So what you can do is say, well, let's multiply all of these by 2, because 2 times 3 will give me 6. And I can make several waters evenly with 6 H's, okay? So that will give me all of these, right? So all I did was multiply them out, and so I have 6 H's, 2 P's, and 6 O's. Well, how many waters can I make with 6 H's? Well, hopefully you guys all said 3. Yes, I can make 3 waters and take all of these H's away, and if I make 3 waters, how many O's will I have left? 3. So I'll have 3 waters, and then I'll have P2O3, and that's what we get here. Okay? Keep going. There we go. All right, rule number 3. When metal hydroxides, so we have a metal with hydroxide, are heated, they decompose into water and a metal oxide. All right, so here we have a metal hydroxide. It's going to break apart into H2O and a metal oxide, so barium with oxygen. Here's just a crisscross and reduce. So you form your water and crisscross and reduce. So barium has a 2 charge, oxygen has a 2 charge. It just becomes BaO. So we have our water and our BaO, and this is already nice and balanced. Rule number 4 says when metal carbonates are heated, remember carbonate is CO3, so metal with carbonate, they decompose into carbon dioxide and metal oxides. Okay, so we're going to break these guys apart. We're going to form CO2 and a metal oxide. So we're going to take Na and put it with oxygen, crisscross and reduce. So pull out your CO2, and Na has a 1 charge, oxygen has a 2 charge, and you're going to get Na2O. Let's try one more. Now here we have a transition metal, so I'm going to throw something else, another challenge into the mix. In order to figure out what I'm going to have, what type of metal oxide, I need to know what charge this copper is. It's not difficult. I just need to know that carbonate has a 2 charge because you all have that memorized. There's only one of them. Therefore, this copper has to have also a 2 charge. So remember that formula? It's the charge times how many there are divided by the number of metals. Well, there's only one carbonate, so 2 times 1, and there's only one metal, 2 divided by 1. So this is copper 2. So in order to form this, I need to know that copper has a 2 charge. It's going to form a metal oxide. So copper and oxygen, 2 and 2 is going to reduce to 1 and 1. And so we get carbon dioxide and CuO. All right, the last rule we're going to talk about for decomposition is this one. Metal chlorates are heated. They decompose into O2 and metal chloride. So chlorates, as you guys recall, is ClO3. Okay, that's a chlorate. And it is a metal chlorate because it's attached to a metal. So we're going to pull out an O2 and we're going to get a metal chloride. So just put your metal with the chlorine, okay? So, and then crisscross and reduce. So sodium has a 1 charge, chlorine has a 1 charge, crisscross and reduce, and you're going to make O2 and NaCl, and then go back and balance it if you need to. Okay, so crisscross and reduce for this. All right, so here are some more examples that you guys can try. So pause the video because I have the answers on the next slide. Try them and see what you get, and I'll show you the answers on the other side. Okay, and here are all the answers. Hopefully you guys were able to get all of the correct answers. If not, and you still have questions, let me know. Okay, good luck.